Hello everyone, this is lesson 1.1 on segment length. This should be written in your notebook, and you should have a little piece of paper with some examples that I'm going to go over pretty soon. So first I want to start with the segment addition postulate. Segment addition postulate. Alright, so we have already been talking about segments. Recall, a segment is part of a line that ends. It doesn't go on forever. We, of course, know addition, adding things together, and we have this new word called postulate. Now, a postulate is an assumption, something that we all can agree is true. That is what a postulate is in geometry. All right, let's get into the postulate. Let points A, B, and C be collinear. So these points do lie on the same line. If point B is between A and C, then AB plus BC, I'm going to give myself a little more space here to really focus on this part. AB plus BC equals AC. Okay, you may be like, what? I'm trying to picture this. It's not coming. Let's break it down. So first we have A, B, and C are collinear. I have 3 points that are in a straight line. Hopefully you did a little straighter job than me. And we're also told that B is between A and C. So B must be this one between, and here would be A and C. Now, this assumption, it should be something that's pretty easy for us to agree on. So we've said that AB plus BC is equal to AC. And I'm going to go ahead and color code these parts for me. So I have AB from here to here, BC from here to here, and if I add those together, it should equal AC, which is the whole thing for me. And that should make sense to us. We're really talking about a part. Ooh, let me get my pen ready. We're really talking about that a part plus a part equals a whole. And that's really what the segment addition is about. That's why it's something we can all agree on. We have one part here, one part here. We put them together through addition. We get the whole thing. Okay, so we are going to use this postulate now in our example. So you should have your strip of paper, and we're going to start with example 1 and part A. So in geometry, we do form our own equations. The equations are typically not set up for us. We're going to need to write them. So keep in mind that part plus part equals whole. Here, my parts are from T to U, from U to V, and then my whole thing goes from T to V. So I could say TU plus UV equals TV, right? From here to here, here to here, gives us the whole thing. Now, to make an equation, I obviously don't know what to do with all these T's and U's and V's. I want to replace them with the parts from the diagram. So I've already kind of set up what's going on here. Now I know TU is this x plus 13 part. So part plus part, UV is 2x plus 23, equals whole and TV is the whole thing, which is 12. So to give a little color coding here, I have TU, UV, and TV. Alright, then I'm just going to be going back to solving equations as we have reviewed earlier in this class. I want to work with my like terms of x and 2x, making 3x, and I want to work with my like term constants. 13 plus 23 is 36. I'm going to continue solving here, subtracting 36 from each side. And here I get negative 24. And then finally, I'm going to rewrite what I have here still. Finally, I will divide by 3. And I get x equals negative 8. That is going here. It has asked me for the length of TU. Now, I know that's x plus 13, but now that I know what x is, I want to replace it and figure out the length of TU. Negative 8 and positive 13 leaves me with 5. So from T to U is 5. From U to V, which is 2x plus 23, that's now going to be 2 times negative 8 plus 23, or negative 16 plus 23, which is 7. So here is 5, here is 7, and that does add up to 12. Checking out with that postulate that I used to begin. All right, let's see another one of those. So for part B, we're going to work on setting this up first. Think about the different parts, color code them if that is helping you learn. So I have my part, and my whole. Now you can jump right into the equation. I'm still going to be referencing the parts of these segments. So I have ED plus DC equals EC, the whole thing. Right? And that does match up. ED is in blue for me, DC is in green, and EC in red. Now I will replace these parts with the expression. So x minus 1 plus 8 equals the whole thing for x minus 2. Alright, so this is a different equation than what we have been working with, making it a little bit more challenging having variables on both sides of the equation here. I still want to look at each side and see if there's anything to simplify, which I can add these constants together. Over here, I can call this x plus 7. Alright, from this point, I want to gather all of my x's onto the same side and all my numbers onto the opposite side. I'm going to do that by doing the opposite. This is positive x, and the opposite is negative x. So essentially what's happening is I'm getting rid of it here and moving it over to this side. But since it's negative, I'm left with 4x minus 1x, which is 3x. Now working on getting my numbers to the opposite side, I'm going to add 2. And I get 9 equals 3x. Finally, I'm going to divide, and I get 3 equals x, or x equals 3. All right, time to plug back in here. ED is x minus 1, or replace 3 minus 1, which is 2. EC is the whole thing for x minus 2. So 4 times 3 minus 2 is 12 minus 2, and that will come out to 10. And it should check out that the small part here, ED, which is 2, plus DC, which is 8, equals the whole thing, which is 10, and that does check out. So it's working out the way we want it. All right, just a couple more examples. So here we have JK, KL, and the whole segment KL, or JL, excuse me. I'm going to go ahead and color code first. Then I'm going to get into my equation. I'm going from JK plus, so JK the blue, plus KL the green, equals JL. Replacing with the expressions 2x minus 9, JK, plus x minus 7, KL, equals JL, which is 8. All right, combining my like terms, my x's together gives me 3x, and negative 9, negative 7 is negative 16. Now I'm going to be adding to both sides. 3x equals 24. And finally divide by 3 to both sides. I get x equals 8 here. 8. Alright, I'm asked to find JK, so plugging that 8 in for my x value here. 2 times 8 minus 9, or 16 minus 9, that is 7. JL, ooh, look, that's already given to us. Nice, no solving needed. That comes out to 8. Alright, we made it to our final example. Let's get this segment color-coded. And jump into our equation. So I have HI plus IJ equals HJ. Alright, let's replace with our expressions 2x plus 22, HI, plus IJ, which is 11, equals HJ, x plus 24. Alright, here we have again our variables on both sides. First, we want to look at each side and simplify as much as we can. I do notice that I have constants here that can be combined together. So 2x plus 33 equals x plus 24. Right, everything's combined on each side, variable, constant, variable, constant. I choose which way to move my variables. Typically I subtract where, the smaller one is for the bigger one. So I'm going to do that here, keeping things positive. So I'm moving it from this side, and 2x minus x is x. X plus 33 equals 24. Then I subtract my 33, and looks like it's going to give me a negative here. X is negative 9. Plug back in, so 2 times negative 9 plus 22, or 18 plus 22, that's going to come out to 4. Then HJ, the whole thing, will be negative 9 plus 24, which is 13. And we have made it to the end of lesson 1.1. Congrats to you.